Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math.
All right, welcome back, math students. This is 2.5 in Algebra 1, solving compound inequalities. And so as we get into this, we're going to be looking at writing and graphing compound inequalities. We're also going to solve compound inequalities. And eventually, maybe at the very end of this lesson, we'll be using compound inequalities to solve real-life problems. All right, so let's go ahead and get into our lesson here, starting with a little joke, or a little cartoon here of the day. So this is a Grandpa Superman over there. It says Superman in his later years. Yeah, dang, where was I going? Far Side's always good for a laugh. All right, let's go on into looking at our some information here about compound inequalities. So we've been learning about inequalities so far. And a compound inequality is basically when we take two inequalities and we put them in the same equation or same inequality, and we solve it for the whole thing, or we also put them on the same graph. So it's kind of like you're combining two, inequalities into one. So here's just a picture of that. We see, okay, here's a graph of an inequality. Here's a graph of another inequality. Well, if we just, kind of put those together, we can combine it and make this inequality. So here's the compound one, where it's got the two holes and shaded in between. Or here's another one where we'll see here's an inequality going from this way in the negative direction. Here's one, again, open hole going to the right. And then if we put those two together on the same number line, that now is called a compound inequality. So you notice there is two of these types here. We have one where it's shaded in between, and we would call this one an intersection. So this would be one where we're going to use the word "and" in our inequality, like this here. You can say this inequality and this one, or we could put it all in one long, inequality statement like this, where you have the x, that's the variable, in between the 2 and the 5. So basically everything that's true in this compound inequality would be between 2 and 5. It would equal 2. It would stop at 5, but it wouldn't equal 5. That's what the open hole means. It's there, it starts there, but it doesn't equal that number. So it's everything that's less than 5 and everything that's greater than or equal to 2. Now the other one over here, where it's going the opposite direction, you still have the two holes, but instead of being between, the shading's now in opposite directions. This one's a union, or we would use the word "or" in this one. We're going to see the word "or" in our statement, this inequality or that one. Notice we can't put these together like we did over here in one long statement. It's only going to be for the ones that are joined together, where the shading's joined together and its shading's in between, because we can put the variable in between the numbers. This one, there's no way to put the variable in between the numbers because the variable is going in opposite directions. This one said it's less than or equal to the -2, or this one's greater than 1. All right, so let's keep on working on and going into more. Okay, so in problems 1 through 3 on the extra practice page of your notes, that's what we're going to look at on this slide right here. This is going to be also for 1 through 5, but we'll just look at 1 through 3 first here. We're going to write the sentence as an inequality, and then we're going to graph the inequality on the number line it gives us. So from the little statement here, we're going to write out a compound inequality. We're going to use the variable that it gives us. So number 1, it gives us u, and number u is less than 7, and it's greater than 3. So we're going to write out each one separately, starting with the first one, that it's less than 7. So we're going to say u is less than 7. That should be an easy one to just write out like that. U, the less than sign, and then 7. Then we're going to see the word "and" here. So we're going to put that word then next. We're going to say "and," write the word "and" down. And then we're also going to say that it's also greater than 3. The u is greater than 3. Should also be a fairly easy one to put down as well. U greater than 3. The greater than sign and then the 3. So now at this point, we want to try to put it in a statement that would be very clear and concise. So since it's an "and," we can make that one long statement out of this. That's the best way you want to do these. We want to always change the "and" ones here into those statements if we can. It's going to be the easiest way to write them. So the first thing I'll do to change that will just be to flip this inequality around so that my u will kind of be right there in the middle with the other u next to the and. So if I just flip that around and put the 7 first, flip the inequality sign around so the mouth is still opening towards 7 or arrow is still pointing at u. Then I'll write the rest of it again. This is all the same here. So now the u's are in the middle. So now what we can do is kind of mash those together. We'll say 7, this inequality sign, then we'll have u here, inequality sign, and then the 3. So we put it all together like that in one long statement. See, the u is just, we're just going to kind of mash it together there in the middle to say that u is in between 7 and 3. Now the only thing we'd want to do at this point is when we're writing out this statement, it's always going to be best to go from smallest to largest or least to greatest, because that's the way the number line is always going to go. It's going to go from left to right, smallest to largest. Well, 3 is smaller than 7. That really should go on the other side. So I'm going to do one more flip around here. I'm going to flip everything around here one more time to get my statement correct. So that way 3 goes first, and we're going to flip these inequality signs. The arrow's still pointing at 3, so less than u. U is really the only thing that kind of stayed the same. And then the inequality here will also be flipped around. So again, the arrow is still pointing at u this way. And then 7's there at the end. So that tells you that u is now in between 3 and 7. And doing it that way definitely helps us be able to graph this correctly. So out on the graph, we're going to put some numbers down. So just go ahead and put these numbers down, 0 all the way to 7. Because everything's on the positive side here with 7 and a 3. We're going to put open holes at both of these numbers because there's no little line showing that that's equal to. So they require only open holes on both 3 and 7. And since the u is in the middle, we're going to shade in between here. So we're shade there in between. And that's it. All right, let's move on to 2. Now 2, this one starts off with a number d. We're going to use d for this one. Is less than negative 2. That should be fairly easy to say. D is less than negative 2. This one uses the word or, so this one's not going to be an and or intersection where it's intersecting on the shading. It's going to actually be a union where they're going to be shaded the opposite direction. So the word or goes down, and then we're going to write the other statement over here using D again. It's greater than or equal to 2. So this time it's going to require that little line. So D is greater than or equal to 2. So there's our 2 inequalities. So at this point, since it's already disconnected here with the or, we're not going to connect it all together like we did here in this long statement. We're going to keep it this way. So I don't need to do anything more than just circle that, and there's my statement there. There's my inequality sentence that I wrote. And now I just need to graph this. So again, put some numbers down on your number line. I just needed to go from negative 2 to positive 2. And at negative 2, we're going to be putting an open hole, and at positive 2, we're going to go ahead and put there a closed hole. Now in this shading, it's not going in between because this one says that it's less than negative 2. It's got to go to the left from here. And this one's greater than positive 2. It's going to go to the right from there. So the shading is going to go in opposite directions. All right, moving on to 3. 3's got a couple decimals in here, so that won't really bother us until we get down to maybe graphing these. We're going to use the letter S for writing out our inequality sentence. So S is no less than negative 2.4. So no less than, that's an interesting one. It's which symbol is that going to be? Is that going to be a less than or a less than or equal to? Is it going to be even greater? It could be even greater than. So if it's no less, that means it can't be any less than something. It means it could be greater than, though. So it can't be any less than a negative 2.4. So it's going to be like this. S is greater than or equal to negative 2.4. Because that shows you that it's not going to be any less than this number. So it can be equal to this number, because if it is equal to this number, then it's not less than it. Or it could be greater than this number. So S is greater than or equal to that number. Then we have the word and. So this one is in intersection. We're going to be shading in between this one. The other one says fewer. S is fewer than 4.2. So fewer kind of is the same thing as saying less. So S is less than 4.2. So because this one again is an and, let's go ahead and do the same thing as we did on number 1. Put it in this long statement here. So the first thing I want to do is I want to get my S's kind of in the middle on each side of this and. So I need to flip around this one here because this one's already got the S next to and. Let's flip this first inequality around. So now it looks like this. Negative 2.4 goes first. We flip the inequality sign. Now S is here. And now we can just mash together those S's to write our inequality statement. So it's going to go negative 2.4 is less than or equal to S is less than 4.2. Now this one has it going already from least to greatest. The negative number is smaller than the positive number, so that is in the right order. So we're just going to go to our graph now at this point. Let's put some numbers on the graph. So I need to go from negative 3 to basically negative 5 to include these numbers. So if I put some numbers down here, negative 2.4 is going to be in between negative 2 and negative 3, a little bit closer to negative 2 though. And then the 4.2 is going to be pretty close there to 4. It's between 4 and 5, but much closer to 4. So just kind of do your best guess at right about where it's at. Obviously I'm not going to be perfectly accurate. I didn't measure anything here. I'm just kind of putting it in there, just eyeballing it. And then our shading, this one again is in between because it's connected together. Our statement shows that the S is in between these two numbers. Alright, let's move on to looking at 4 and 5. Okay, so I'm going to let you pause the video here for a moment. Try to do number 4 and 5. And one has or on 4, the other one has an and on 5. So go ahead and do the same thing, write that statement, and then graph that statement on the graph, the number line. And then go ahead and play the video again, and then check your answers with me. Okay, so hopefully you have answers for both 4 and 5 that you are now checking. So here we're going to use C. C is more than negative 4. So that's a greater than. More than is the same as greater than. The word or is there, so we're going to put the word or in our statement. And C is also going to be at most a negative 6.5. Now this one might have challenged you a little bit, but the most it can be is this number. So it can be less than that number, or it could equal that number. So it's going to be C is less than or equal to that negative 6.5. Alright, so since this is an or, we are done with that one. There's nothing more to do, so you could just circle that. There's your statement. Now we go to the graph. So we're going to put some numbers down there. From 0 to negative 7 should cover it. And then we're going to put some points down there. There's our negative 6.5 going down in between the negative 6 and negative 7. And the negative 4 is right there. That's easy to put. And then our or means we're going to be shading the opposite directions. So for this one, we're going to be going that it's less than this negative number here, negative 6, but it's also greater than negative 4, so it's going to be going to the right from negative 4. Number 5 has C again. It's no less than a negative 1.5. So again, no less. We saw that one before. That's a greater than or equal to, so C is greater than or equal to negative 1.5. The word and means we're going to put the word and in our statement. And the C is also less than 5.3. That's an easy one. Just C less than symbol and 5.3. Now since we have the and, let's go ahead and try to write this all in one long statement. So I'm going to get my C's together in the middle. I'm going to flip this first one around. So that way now I have the C in the middle. I'll rewrite the rest of this here. And now I'm just going to mash together the C's, kind of where I get rid of my and. And so I'll write out the statement this way with the negative 1.5 first, less than or equal to C, less than 5.3. So again, as long as you have it with the smaller number first, the bigger number last, then you're in the right order. Another way to see that is your inequality sign should always be less than symbols. The arrow should always be pointing kind of in the negative direction. That means you're also in the right order as well. The graph should look this way. We had some numbers from negative 2 to 6 should cover this. And we're going to put a negative 1.5. It's right there in between negative 1 and negative 2. We're going to put 5.3. Now it's going to be an open hole at 5.3. I just kind of guessed about where that would be. It's a little closer to 5. And then it's going to be shaded in the middle. It should be shaded in between. Alright, so hopefully if you made any mistakes there, just go ahead and fix your paper. And then we'll move on. Alright, so here's our joke of the day. What city are you in when you drop your waffle on the beach? What city are you in when you drop your waffle on the beach? You're in San Diego. San Diego. Now, if you don't know where San Diego is, that is south of us, about 2 to 3 hours down south. All right, let's move on to our next set of problems. Okay, so we're going to now start to solve compound inequalities with the word and that's going to be the ones that's like this. So when it's the word and, it's already been combined together. And we're not going to do these two, actually. I'm just showing it to you. This is the way it will look right here, all in one long statement. So when you see the one long statement, you know it's the one that's got the and, the intersection one, that the shading is going to be in between. They're also going to solve ones with the word or. You know, if it has the or, we will see the or. And it's going to be separate to a separate inequalities. We'll solve them separately, and then our shading will be going opposite directions from those two. Okay, so in 6 through 10 on the extra practice, we're going to be solving the inequality and then graphing the solution on a number line, as we saw before. So the first thing is to solve the inequality for the variable, and since on number 6 it's all connected together, you don't see any actual words, there's no and or there's no or, that tells you this actually is an and. If we wanted to separate it out, we could. You know, we could have two inequalities here. We would just have to use this in-between part twice. So we could say 4 is less than x minus 3. That would be one of the inequalities. And we can also say that the x minus 3 is less than or equal to 7. That would be another inequality. So there is two inequalities there if we wanted to separate it out. But we'll keep it all together this way. I think it's just as easy to solve it being together. So we go from the middle part here to get x by itself in the middle. So we just need to get rid of this minus 3. So we're going to add 3 to the middle there to be able to undo that 3 there, and then x will be by itself. But since I'm adding 3 to the middle part, we got to add 3 to both ends as well. So we're kind of like doing two inequalities all at once here. So we're going to add 3 to the 4 on the right, on the left side, and we'll add 3 to that 7 on the right side. And then we'll just go ahead, simplify this. 4 plus a 3 is going to start with giving us a 7, and then the inequality sign, get to that one. And now the 3's there will cancel, and it leaves us just with x in the middle. And then our next inequality sign, less than or equal to, and then 7 plus 3 gives us 10. So there's our answer, and it is in the right order. 7 is smaller than 10. It's all going in less than direction. So that's correct. That's our answer for this one. As we go ahead and graph this one, we're going to put 0 all the way to 10, and go ahead and put 7 and 10 on here. Open at 7, but closed at 10, because 10's got the equal to on that one. And then we're shading it in between the 7 and the 10, because x is in between that. Number 7, we have again another one all connected together. So again, this is going to be one where shading is going to be the same way in between the two points that we have on our graph. On this one, we have g as the variable, negative 5 times g. So again, if we wanted two inequalities, we'd use this negative 5g twice. 15 is greater than or equal to negative 5g would be one inequality. And then negative 5g is greater than or equal to negative 10 is the second inequality. But again, like I said, just like up here, we could solve these at the same time. We start in the middle. What do we need to do to this middle term to get g by itself? And that's to undo multiplying by this negative 5. So the opposite of multiplying is to divide by the negative 5. So negative 5 divided by negative 5 would give us a 1g for the middle. But again, whatever we do here, we're going to do on both ends, both left and right. So we're going to divide 15 by negative 5. And we'll also divide negative 10 by negative 5. So as we do that, the first part, 15 divided by negative 5, that's going to give us, well, we'll cancel these out, of course, yes. It's going to give us negative 3. And then we have the inequality sign greater than or equal to. So greater than or equal to. Now notice what happened. I didn't put a greater than or equal to sign. I actually put a less than or equal to sign. We've already learned this. This is when you're multiplying by a negative, you have to switch the sign. So the same thing's going to be true in a compound inequality. When we multiply by a negative, or if we divide by a negative, we're going to switch our inequality signs. And that's what you see what happened here. So that might have surprised you, as it was, a less than or equal to. It's not the same sign. It's going to be flipping because we're dividing by negative 5. So over here, we got a g in the middle now. So g's there in the middle. And notice what's going to happen here as well. Since we're dividing by negative 5, this sign's going to do the same thing. It's going to flip the other way. and then negative 10 divided by negative 5 is a positive 2. So by flipping it is now in the right order. Negative 3 is smaller than 2, and it's got the less than signs both here, so the arrows are pointing to the left. That's the correct order. That's what we want for our solution. Let's go ahead and put those on a graph. So number the graph, I numbered from negative 3 to 2, and we're going to go put a closed hole on both negative 3 and at 2, and since G is in between here, it's an AND one, it's an intersection, our graph is going to be in the middle. Everything that's true, everything that would make this statement true is in between negative 3 and 2. Any of these numbers that we put in here for G would be true. Alright, number 8, you'll notice on this one it has an OR, so it separates them out always with an OR. So we're going to solve each one separately. Starting with the one on the left, Z plus 4 is less than 2. We're going to first subtract 4 from both sides of that. And so that's now going to give us 4's will cancel. We'll get Z is less than negative 2. Because we get 2, take away 2 away from negative 4 gives us negative 2. And then we're going to put the word OR. Remember we have an OR up here, so we're going to put the word OR in our solution. And then over here we have another inequality. The second inequality to solve is negative 3Z is less than negative 27. So we need to get Z by itself by dividing by negative 3. Just like we divided by negative 5 up here, we'll divide by negative 3 on both that side and on the side where negative 27 is. And so this time when we're dividing by negatives, just like up here we saw the sign flip, we're going to see the sign flip again down here. So Z is going to be greater than 9. So the sign flips, 27 divided by negative 3. Since they're both negative, it's a positive 9. And that is the answer. You can just leave it that way. You can say that's our answer right there with the OR in between. And now if we graph this, we're going to put the negative 2 and the 9. So I'm going from negative 2. Now notice what I did on this one. Since that was a pretty long spread, and I think it was going to be probably more than these lines on my number line, I just started to go every 2. So I went all the even numbers. So I just went by 2's here, negative 2, 0, 2, 4, 6, 8, 10. So it tells me that 9 is going to be right here in between 8 and 10. So we'll put a open hole at negative 2, open hole at 9. And then this time the shading should be going opposite directions. This one it's less than negative 2, and the other one is going to be greater than 9. Going in opposite directions because it's a union, it's an OR. Alright, let's move on to 9 and 10. Okay, so 9 and 10. So these ones are going to take a little bit more time just because they're more multi-step inequalities to solve. They're not just solved in one single step like the ones we just saw a second ago. So here's the one with a word OR. So it has two separate inequalities. So when we eventually get down to the shading part, it should be shaded in opposite directions. So we'll start with just solving this first inequality. 2t plus 6 is less than 10. We'll start by getting the 2t by itself. So I'm going to subtract 6 to undo that number 6 on the left side, and then subtract 6 from the 10 on the other side of this inequality symbol. And so that 6's cancel, leaves me with just 2t now on the left of this one. Our inequality sign stays the same, and then 10 minus 6 is 4. We just now divide by 2. So when we divide by 2, we're going to see 4 divided by 2 is 2, so t is less than 2. Inequality sign does not flip. We're not dividing by negative here. Now on this one here, we're going to do the same thing. We're going to get this negative t by itself by undoing this plus 7. So you're going to subtract 7 from both sides. And so as we do that, so we got cancel 7's out. And so we'll get t now by itself on the left side, our inequality symbol. 2 minus a 7 is a negative 5. And so now to get the t to be positive, we just need to multiply both sides by a negative 1. That way it just changes the sign. So multiply the negative t by negative 1, and then multiply the negative 5 by negative 1. So that gives us a positive t here. But it will change the direction of our inequality sign because we're multiplying by negative. So it's going to be a t is now greater than or equal to 5. So our solution, I'll put it up here very clearly, we have t is less than 2 or t is greater than or equal to 5. Alright, so for the graph, let's put numbers on our graph here. So 0 to 5, and then we're going to go and put a open hole at 2 and a closed hole at 5. And since it says or, we should be shading in the opposite directions. You just want me to double check. T is less than 2, which means it's going to go off to the left, and T is greater than 5. So yes, it goes off to the right. Alright, let's move on to number 10. 10 is all one long compound statement. So this is one where the shading is definitely going to be in between. Your X is in between the two inequality symbols. So the first thing we're noticing is a 1/3 in front of this quantity 6x plus 24. So the first thing we need to do is distribute 1/3 into 6x and into 24. So I'm going to multiply 1/3 by both of those terms to get rid of these parentheses. So the first thing I'll do is just start by writing -8 is less than or equal to. And now when I multiply 1/3 times 6, now this should be fairly easy. If you have a 1 over some number, so if 1's your top number, the bottom number, as long as that goes into these, it should be very easy. It's basically like saying 6 divided by 3. That's all that is. So we know 6 divided by 3 is going to give us 2, so it's going to start out with 2x. And this one will be like 24 divided by 3. So we know 24 divided by 3 is 8. So that was fairly easy to do. Don't be intimidated by fractions all the time. They're not that bad. They're not that intimidating once you get used to them. And then you have to just write your less than or equal to the 12 at the end of this. So now we have an easier equation, no fractions anymore. And what we need to do is get the x by itself in the middle, in between these two inequality symbols. So we have to start by undoing this plus 8. So we have to subtract 8 here in the middle. But whatever I do to my middle, I'm going to do to the both left and right sides of this long statement. So I'm going to subtract 8 from the -8 and subtract 8 from the 12 on the other side. So when I subtract here -8 and -8, those don't cancel each other out. They may actually make a bigger negative, -16. Then we have our inequality symbol, and then these 8's cancel here, so that leaves me with just the 2x in the middle. Then the other inequality symbol, and then 12 minus 8 gives us 4 on the other side. So now we need to undo the 2 here. 2 is multiplying x, so we have to divide by 2. Again, whatever we do in the middle, we're going to do to both left and right sides of this. So -16 divided by 2, and also 4 divided by 2. So as I see, okay, what's -16 divided by 2? That's going to give me a -8. And then we'll have our x in the middle, so inequality symbol, x in the middle, and then 4 divided by 2 is 2. So here's our long statement. This is our answer. X is in between these two. Notice that the smaller number is on the left, so this is in the right order. The inequality signs are facing toward and pointing towards the negative direction, less than symbols. So that's the correct answer you want. Now let's just go ahead and put that on the graph. So I'm going to go from -8 to 2, but again, I'm going to do my even numbers here on this one. So 2, 0, -2, -4. So I'm going by even numbers. And so I'm going to put closed holes on both of these. So closed hole at -8, closed hole at +2, and the shading should be in between because the x here is in between these two. Now you can always double check this. If for some reason you got this wrong by putting, by just double checking each inequality, you can do that. You can say, okay, x is got to be greater than the -8. So it's got to be greater than, it's positive direction, it's going this way. So the shading is going the correct way from -8, and x is less than 2. It's got to be going in this direction to the left, so it's going in the correct direction from 2. Yes, it's in the middle in between these. Okay, here's our last problem in this lesson. It's a real-life situation problem. It says a certain machine operates properly when the relative humidity H, that's our variable, satisfies the inequality that's given to us there. Solve for H to find the range of values for which the machine operates properly. So an inequality is always a range of numbers, a range of values. That's why we have an inequality. If an equation with an equal sign is one single value, that'll make it correct. But this one's a range of values, and so that's why we want to use a compound inequality here to find this range of values that it can be operating properly between. So I'm going to go ahead and write this one down, just rewrite it here, and let's go ahead and start solving it. So H is in the middle. It is one of those compound ones, which is a intersection. We're not going to need to graph this one, we just want to find the solution. So we start by getting the 2H by itself. I need to undo this minus 100, so I got to add 100 to the middle, which means I'm going to add 100 to the left side, the negative 60, and to the positive 60 on the right. So that's now going to give me over here, if I take 60 away from 100, that's going to give us 40, our inequality symbol. The hundreds cancel in the middle, so it's just leaving us a 2H, the inequality sign, and then 160 over here when I add those together. And now I just need to undo the 2. It's here in front of H, so I have to divide by 2 to do that. So I'm going to divide everything here, the left side, the right side, everything by 2. And so we're going to see 40 divided by 2. That's going to give us 20, and then our inequality symbol. Notice I'm not changing the direction of the inequality symbol. I'm not dividing by a negative. And over here these 2's cancel, so then we have H then in the middle, our inequality symbol, and then 160 divided by 2, that's going to give us 80. So that's our solution right there. So basically, to answer the question, as you kind of understand the solution for this, going back to this machine, the machine operates properly when the humidity is between 70 and 80. So that's what it's going to be. When the humidity is between 70 and 80, that means the machine's going to operate properly. Okay, so humidity, if you're not sure about even what humidity is, it's pretty much like the moisture in the air. So it's going to be a moisture in the air. So that's when, if it's the humidity, if just on a normal day, we live in kind of the high desert here in Antelope Valley, so we don't get a lot of humidity here. But if you go to some place back east, like let's say Florida, Georgia, some of those states, they get a lot of humidity there. So their humidity is actually really high there. So we get very low humidity. Our humidity would be probably closer into this 20 area. Their humidity over there might be closer to the 80, but it's saying, okay, the range here is between 20 and 80. If it's higher than 80, if the humidity in the air is higher than 80, not good. Or if the humidity in the air is lower than 20, which means lower than 20 means it's getting really dry, higher than 80 would mean it's getting really moist. So that's why it needs to get in between that range. All right, so that concludes our lesson on 2.5, and I'll see you on our next one.